Ever wonder how your house magically stays perfectly cool when it is boiling outside, or cozy when it freezes? It is not magic, it is your HVAC system. HVAC stands for heating, ventilation, and air conditioning. Think of it as the lungs and circulatory system of your home. It breathes in, it breathes out, it regulates, and it does a lot more than just blow hot or cold air. It controls humidity, it cleans your oxygen, it keeps you alive and comfortable. Yet, most of us never think about it. Not until it breaks down on a 100-degree day. Today we are changing that. By the end of this video, you will know exactly how your HVAC system works. You will know the major parts. You will know the science. And best of all, you will know how to keep it running smoothly to save money on your energy bills. Let's pull back the drywall and look inside. Let's start with the biggest myth in home comfort. Most people think air conditioners create cold air out of nothing. They don't. It is actually the exact opposite. Air conditioners don't add cold. They remove heat. It is a pure physics game of heat transfer. To understand how, we need to meet the secret weapon: refrigerant. This is a special fluid that travels through copper lines in your system. It changes easily from a liquid to a gas, absorbing and releasing heat as it goes. The process starts inside your house at the evaporator coil. Your system's fan sucks warm, humid indoor air across this freezing cold coil. The refrigerant inside the coil drinks up the heat from your air like a sponge. As the air loses its heat, it gets cold. The fan then pushes this newly cooled air right back into your rooms. But now, that refrigerant is holding all your house's unwanted heat. It travels outside through insulated pipes to the big metal box in your yard. This box houses the compressor and the condenser coil. The compressor squeezes the refrigerant, raising its temperature and pressure. Now it is hotter than the air outside. A giant fan blows outdoor air across the condenser coil. Because heat naturally moves toward colder areas, the heat escapes into the outdoor air. The refrigerant cools down, turns back into a liquid, and heads back inside to repeat the cycle. Over and over, round and round, stripping heat from your home. Think about a building like a giant cube under the sun. Heat is constantly pushing its way inside through the walls. This is the solar load. To keep things comfortable, your cooling system has to match that heat load exactly. It has to scoop that exact amount of energy up and throw it out. But how do we actually move that thermal energy around? You usually have two choices: forced air or hydronics. Forced air uses a massive fan to push conditioned air through large ducts. Hydronics uses a small pump to circulate water through tight pipes. Water holds way more heat than air, making hydronics incredibly efficient. No matter which one you choose, you still have to deal with air quality. If you just circulate air inside a sealed house, it gets stale. But if you burn fuel for heat, you also have to worry about exhaust. A bad system can trap dangerous gases inside, like carbon monoxide and nitrogen oxides. That's why proper venting and air exchange are literal lifesavers. And geography changes everything. Look at how climate affects energy consumption. In a dry climate, cooling a building might only take 12 kilowatts. But bring that same system into a humid climate, massive overload. An energy surge of over 300%, because the system has to work overtime just to squeeze the heavy moisture out of the air. To beat these massive energy spikes, we look at advanced heat pumps. These systems use a forced reversal mechanic. Instead of just creating heat, they pump fluid to actively force heat from a cold zone into a hot zone. It's working against nature, but it's incredibly effective. You can deploy this power in two ways. A central all-air system uses a big central pump to split air across the whole building layout. Or you can use a ductless split system. This connects an outdoor compressor directly to an indoor wall unit with a simple line. No heavy ductwork required. But if you want the ultimate efficiency, you go underground. Deep earth guarantees total thermal stability. Once you dig past a certain threshold, the temperature stays a steady 18 degrees Celsius all year round. Geothermal systems leverage this. They use the earth as a heat source in the winter and a heat sink in the summer. Finally, we tie it all together with an enthalpy recovery wheel. This spinning matrix sits right where your indoor and outdoor air streams cross. As the warm indoor air gets pushed out, the wheel steals its heat and moisture. Then, it spins and transfers that energy directly into the incoming cold outdoor air, preconditioning the air for free. Maximum fresh air, minimum wasted energy. But what happens when winter arrives? The cooling cycle stops, and your heating system takes the stage. Depending on where you live, you likely have one of two systems: a furnace or a heat pump. Let's start with the classic furnace. Furnaces create heat by burning fuel, usually natural gas, propane, or electricity. When your thermostat calls for heat, a burner ignites inside the heat exchanger. Think of the heat exchanger as a sealed metal chamber. It gets incredibly hot. Your system's blower fan pushes cold indoor air over the outside of this hot metal chamber. The air warms up instantly. Crucially, the toxic fumes from the burning gas stay inside the chamber and go safely up a vent chimney. The clean, warm air is then blown through your home. Now, what if you don't have a furnace? You might have a heat pump. Heat pumps are fascinating. They don't actually create heat. Remember the air conditioning cycle we just talked about? A heat pump simply runs that exact cycle in reverse. Even in freezing weather, there is still thermal energy in the outdoor air. The heat pump absorbs that outdoor heat and pumps it inside your house. It is incredibly efficient because transferring heat takes way less energy than creating it. The average person takes about 20,000 breaths a day. Every time you breathe in, your lungs consume oxygen. Every time you breathe out, you dump carbon dioxide, or CO2, back into the room. Now imagine a modern house. It is built to be completely airtight to save energy. If you lock a few people and pets inside a sealed box, that air gets consumed fast. The oxygen levels slowly drop. The CO2 levels spike. And it's not just your lungs doing the consuming. Your gas stove consumes oxygen and releases combustion byproducts. Your cleaning sprays, new furniture, and plastics release chemicals into the air. If you don't do something about it, you end up breathing recycled, polluted exhaust. This is why we need air exchange. Air exchange is the process of physically swapping out that consumed, stale indoor air and replacing it with fresh, oxygen-rich air from the outside. Think of it as the house taking a breath. An HVAC system achieves this using a calculated balance of pressure. Inside your home, return vents act like exhaust pipes. They pull the high CO2, consumed air out of your rooms, and send it toward the ventilation system to be kicked out of the house. At the exact same time, a dedicated fresh air intake pipe draws clean air from outdoors. This new air passes through a heavy-duty filter to strip out pollen, dust, and pollution. Then, the supply vents distribute that fresh oxygen throughout your home. You get clean air to consume, and the bad air is thrown away. HVAC uses filters to purify the air. It starts with polluted air passing through an active carbon filter. This stage is great for trapping odors, gases, and smoke. Next, the air hits a HEPA filter. This is the heavy hitter, catching tiny particles like pollen, dander, and dust. A powerful fan keeps the air moving smoothly through the system. Finally, a diffuser spreads the freshly cleaned air evenly back into your room. And just like that, you have crisp, clean air to breathe. As a homeowner, managing this air consumption is simple. First, never block your return vents with furniture. The system needs to pull that consumed air out. Second, check your outdoor intake vents once a year to make sure leaves or snow aren't choking the fresh air supply. Temperature makes a room comfortable, but proper air exchange keeps it healthy. Thanks for watching. If you want to know more about keeping your home's air fresh, leave a comment below, and we'll see you in the next video.